Welcome to This Explainer. Today, we're cracking open the strategic playbook for the wind energy sector. Look, we all know about wind's massive potential, right? But the real difference between a fragile project and one that's built for the long haul, that almost always hides right in the supply chain. So we're going to dive deep into how the biggest players standardize and, more importantly, disclose their mitigation of critical material risks.
Right off the bat, let's establish our baseline. We're looking at the SASB standards, now managed by the IFRS Foundation, by the way. This framework is essentially the rulebook we're decoding today, specifically tuned for the wind technology and project developers industry. And trust me, it's way more than just some dry compliance checklist. It's actually about translating these really complex operational risks into clear, comparable financial language that the market can actually digest.
Think of this as your executive briefing. Here's our roadmap for today. We'll start with the SASB wind standard, move into the critical material threat, break down the 4 pillars of mitigation, look at materials efficiency and ecology, touch on protecting the workforce, and wrap up with the bottom line. Let's jump right in.
Section 1. The SASB wind standard, decoding the framework.
So, the SASB framework, specifically designated as RWT, targets companies globally that are manufacturing turbines, blades, towers, and even the folks managing the actual projects. The fascinating thing here is that this acts as a major strategic management tool. It essentially forces companies to quantify their physical risks and tell their investors exactly how they're handling them to stay viable in a totally cutthroat global market. Because, what happens when the wind is blowing, but the physical supply chain you need to actually build the turbine is completely broken?
Which brings us perfectly to Section 2, the critical material threat and vulnerabilities in the supply chain.
The standard is super precise about this. It explicitly defines a critical material using a dual criteria. First, the material has to be absolutely essential to the product's functionality. Like, you literally can't build the thing without it. And second, it has to face a tangible risk of supply restriction. We're talking about restrictions from geopolitical concentration, sheer physical limits, crazy competition from other tech sectors, or just wild price volatility.
This right here is what you might call the invisible engine of the wind industry. While we all see those massive steel towers and huge fiberglass blades, the highly efficient direct drive turbines, they rely entirely on these invisible yet absolutely crucial elements. We're talking rare earths like neodymium and dysprosium, along with critical minerals like tantalum, tungsten, and platinum group metals. And here's the kicker. Because these elements have incredibly low substitution ratios and their deposits are often hoarded in just a handful of countries, they represent a massive single point of failure bottleneck for manufacturers. So how do these companies actually prove they're surviving this bottleneck?
That takes us to Section 3, the 4 pillars of mitigation, essentially the disclosure playbook.
Under the SASB standard, companies have to put their cards on the table and detail exactly how they disclose their mitigation of these critical material risks. They do this across 4 vital reporting strategies. First up, supplier diversification, proving they aren't just relying on a single region or vendor for their rare earths. Second, material stockpiling, building up a strategic buffer against sudden global shortages or price spikes. Third is the procurement of substitutes, which means actively developing alternative materials through intense R&D. And finally, investments in recycling technology, trying to reclaim these critical elements once a turbine reaches the end of its life. By laying out this specific playbook, companies are showing investors exactly how they plan to protect their supply lines and shake off their reliance on volatile raw materials.
Moving on to Section 4, materials efficiency and ecology, and how we minimize the impact.
To really prove material efficiency, companies have to contrast 2 major factors across different turbine classes, whether they're onshore or offshore. They have to disclose the sheer weight of the top 5 materials they consume, things like steel, carbon fiber, and copper. But the real magic is tracking the average top head mass, measured in metric tons, against the actual megawatt capacity factor that the turbine generates. It's a critical efficiency ratio. Basically, are you using less steel and fewer critical minerals to generate more power? Hitting that sweet spot is the ultimate indicator of a company's technological edge.
But taking a holistic view means looking closely at the environment the turbine actually operates in. Companies are required to disclose any order backlog cancellations that are tied directly to community pushback or ecological concerns. Think noise emissions or strict land use requirements. This pushes developers to get creative and integrate advanced physical technologies. We're talking about SCADA operational control software, radar for wildlife detection, ultrasonic transmitters, and even the ability to do sudden curtailments to actively mitigate wildlife risks like bird and bat deaths. It's all about ensuring smoother project approvals from day one.
All right,
Section 5. Protecting the workforce and health and safety in operations.
Look, building and maintaining these massive structures, especially in extreme offshore environments, is inherently hazardous work. The magic number to know here is 200,000. This is the baseline for the Total Recordable Incident Rate, or TIRR. It standardizes safety reporting by calculating incidents against 200,000 hours worked. Why that number? Because it perfectly represents 100 full-time workers putting in 40-hour weeks for 50 weeks a year. And the most crucial part? Companies have to report these safety rates not just for their direct, on-payroll employees, but for their contract workers too. So absolutely no workplace hazards get hidden off the main books.
Finally, Section 6, the bottom line, proving resilience. When you zoom out and look at all these data points together, you realize something pretty cool. Mastering these disclosures totally transforms what might seem like super dry compliance reporting into a really dynamic, compelling story. By being completely transparent about everything, from rare earth stockpiling to worker safety and community impacts, these wind technology companies are basically proving to the market that their operations are bulletproof enough to withstand global shocks. So I'll leave you with this final thought to chew on. As we hit the gas on our global transition to green energy, we have to look past just the spinning blades. We really have to ask, can a wind turbine actually be considered renewable and sustainable if the critical supply chain behind it is fragile and opaque? The companies that are going to dominate the next decade are the ones answering that question with absolute transparency. Thanks for hanging out with me for this explainer, and remember to keep questioning the systems that power our world.